Okay, so this will be page 2 of your review packet. These problems actually get a little bit harder, but we still know how to do these based on our lessons. So we look at number 9, the big difference now between the first page and number 9 is now we have a division or a fraction sign. So that should trigger your mind. Think about the last lesson that we did about quotients. And quotients are actually the exact opposite of multiplying monomials. They're actually dividing monomials. So our first step when we do these is to notice if there's any coefficients. So in this case, there are coefficients. We have 18 and 3. So when we have coefficients, we're actually going to divide them. So we do 18 divided by 3, and we will get 6 when we do 18 divided by 3. So that will be step 1, divide your coefficients. Then just like with multiplying monomials, we keep the base. But now, instead of adding the exponents, because we're using division, we're actually going to subtract the exponents. So this will be 12 minus 2. So that's almost simplified, but we do know how to actually go ahead and simplify the 12 minus 2. So we keep the 6, keep the y, 12 minus 2 is 10. So this will actually be your final answer for number 9. Again, the 6 comes from 18 divided by 3. The 10 comes from doing 12 minus 2. Okay, so if we take a look at number 10 now, number 10 is one of those product of power rules because we have an exponent on the outside of the parentheses, but we also have more than one x on the inside and more than one y on the inside of the parentheses. So this one actually requires more than one step. So the first thing I would suggest doing here is working just inside the parentheses first. So just taking this problem and working it out and keeping this 2 on the outside to work with later. So again, kind of keeping this 2 on the outside and handling it later. So if I look, on the inside I have a 4 and an 8, so those are coefficients. So we know when we do the product rule that we actually multiply those coefficients. So we get 32. Then we have 2 sets of x's. We have x, there's nothing here, so we know this is x to the first power. And we have x to the fourth power. So really what you're going to do is add the 1 plus the 4. Keep now the y, and again there's nothing on that first y, so we know that that's 1. And then on the second y, there is a 5. So we're going to add the 1 plus 5, just like if it were a multiplying monomials problem. So we can go ahead and, let me make this a little bit smaller, simplify that by just adding those exponents on the inside. So again, keeping that squared on the outside. So keep the 32, the x, 1 plus 4 is 5. 1 plus 5 is 6. So this becomes 32, x to the 5th, y to the 6th squared. And then now that we are here, this actually just becomes a power to power problem because we have the exponent on the outside with some exponents and bases on the inside. So again, we're distributing that 2 to everything on the inside. And when we do that, we'll get 32 squared, x to the 10th, y to the 12th. And there's one last thing you can do to simplify this problem, and that's we actually know what 32 squared is. It's a big number, but we can calculate it by doing 32 times 32. So 32 times 32 is 1024, and then we keep x to the 10th, y to the 12th. So that will be actually our final answer to this problem. So again, there are a lot of steps. The first thing that we did was we just simplified the inside by combining our x's by adding their exponents, combining the y's by adding the exponents. Then we distributed this 2 in to everything on the inside. Then the last step was just doing 32 squared. Okay, so now if we take a look at number 11, Same type of problem. We have multiple x's on the inside of these parentheses, and we also have a power on the outside. So we will follow the same sort of pattern here by first just simplifying the inside here and then working with this 3 later. So again, what I like to do is just kind of have this set up with a 3 on the outside so I don't have to worry about it. Then on the inside, we have a 3 and a 2 as coefficients. So we multiply 3 times 2 and get 6. We have 2 sets of x's, so I'll combine them into one x and add their exponents. So we do the 5 plus 6, and we'll get to the 11th power. And we only have one y, so I'll keep that y and square it, because there's a squared here and there's nothing to combine it with. So that's our first step, is just to simplify the inside using the product rule. Then we can get rid of this 3 by distributing it into the parentheses using the power to power rule. So what that would look like is we would keep the 6, and it would be to the 3rd power now from that outside. Keep the x, but now it would be 3 times 11, so 33. Y, and then do 2 times 3 to the 6th power. So we're almost done here. The last step is that we can actually just simplify 6 cubed. So 6 cubed is 216, x to the 33, y to the 6th power. So that'll be our final answer for number 11. Okay, so now we have 12. 12 will probably be one of the harder problems that we have because there's actually a lot more simplifying we have to do, but still we know how to handle it. So what I would do first is I would just simplify this part of the expression, because notice how it has 10x to the 5th y cubed all to the 2nd power. We can simplify this by just using the power to power rule. So what that would look like is distributing this 2 into everything on the inside. So instead of now just 10, it'll be 10 squared from that 2 on the outside, x to the 5 times 2, so it'll be to the 10th power, y to the 3 times 2, and that will be to the 6th power. And then we're going to actually, although we didn't do anything with it, we're still going to keep that expression behind it and just copy this down. So I'm just going to copy 4x y squared because I haven't really done anything with it. But all I did here was simplify this 2 on the outside by distributing it in. Make this a little bit smaller. Okay, so now that we're here, the next step before you move on is I would just maybe simplify this 10 squared. So 10 squared we know is going to be 100. So I'm just going to copy everything else down, but just change the 10 squared to 100. Again, I'm just copying this problem down, but making the 10 squared 100. Okay, so now that we're here, this is actually just the product rule. So notice we have 104. Those are our coefficients. So we can multiply them together to get 400. We have x to the 100 and just x. So we know because that's just an x here, we're actually going to do 100 plus 1. And then keep the y and do 6 plus 2. So again, multiplying 100 times 4, adding the 100 on this x with the 1 on this x, and adding the 6 on this y with the 2 on this y. So our final answer here becomes 400, x to the 100, or 101, and y to the 8th. And that will be the final answer for this problem. So again, a lot of steps here. You want to try and take your time on these types of problems. And again, on your test, when you do this, you do want to show your work. So even if maybe one of these steps is skipped, that's fine, as long as you're showing me how you got to your final answer and not just writing your final answer. All right, so 13 is actually a little bit easier if you remember the quotient rule. So notice we have x to the 12th divided by x to the 3rd. There's no coefficients here, so we can skip the coefficient step and just keep the x and subtract your exponents. So do 12 minus 3. Our final answer here is just going to be x to the 9th. So again, a pretty simple one as long as you remember that when you have the quotient rule, you subtract your exponents. Okay, number 14, another example of the quotient rule. So this time we do have coefficients. So remember with the coefficients, with the quotient rule, we actually are doing 25 divided by 5. So when we do that, we get 5. We keep the x and subtract the exponents on the x's, so 8 minus 4. Keep the y and do 12 minus 3, because those are exponents here. So our final answer when we simplify it is 5x to the 4th by doing 8 minus 4, y to the 9th by doing 12 minus 3. So this will be our final answer for number 4. And number 15 is actually a little bit tougher because there's an extra step, but we still know how to handle this using both the product rule and the quotient rule. So the reason there's an extra step here is because there's 2 x's on the top of this fraction. So since we're doing x to the 4th times x to the 10th, we can combine those x's on the top by doing 4 plus 10, keeping the y to the 3rd on the top, and then keeping everything else in the bottom to start. So again, my step here was just to combine these 2 x's by adding their exponents together. So that would become x to the 14th, y to the 3rd, divided by x to the 5th, y to the 6th. And then this just becomes a classic example of the quotient rule because we have x's on top and bottom and y's on the top and the bottom. So what we would do is do x to the 14 minus 5. And then notice how this y has a 6 on the bottom and a 3 on the top. So all you're going to do now is just keep the y on the bottom and subtract 6 minus 3. So it's a little bit of a tougher question, but still we're using that quotient rule. So the final answer here becomes x to the 9th divided by y to the 3rd.